Okay, so I'll just say one more time. This is not a comprehensive review in the sense that this isn't exactly like the test. Okay, and there are other question types that you might see, but when I say that, what I mean is there are different versions, variations on different questions. So every type of thing you're going to see, like there's a square root equation on the back. There is completing the square, quadratic formula, factoring, square root property, rational equations, linear equations. So those are all the things we've covered in this unit. But like I said, there are slight variations on those at each step of the way. So solve a linear equation. I'm just going to start in the upper left there. -6 equals 6 parentheses x minus 8 close parentheses minus parentheses x minus 7 close parentheses. A lot of parentheses. What do we do with that? Distribute? Okay. Yeah, 6x minus 48 when we distribute the 6 there. And then what about the minus sign there? Minus 1x plus 7. Okay, good. We change the signs, we have a minus sign like that. Okay, now we can combine like terms. That'll, so negative 48 plus, so we have negative 48 and plus 7, so that'll be negative 41. Okay, and then we do the 6x combined together with the minus x, that'll be 5x. Okay. So we have negative 6 equals 5x minus 41. Can add 41 on both sides. Okay, so negative 6 plus 41 is that 35? 35? Okay, so 35 equals 5x. Yep, so x equals 7 because we'll divide by 5. Okay. Now, if you wanted to check this, you probably would just do it in your calculator, honestly. But if we want to check this, we'd go back and replace the x with 7 and see if this is true. So I'm just going to write down what you put in your calculator. So 6 times 7 minus 8 minus, parentheses, 7 minus 7. And that is negative 6. Okay, so good. Check. Good with this so far? Okay, all right. Well, then we'll take it up a little notch. So we have one of these rational equations. So we got fractions here. Okay, so there are two things we've always had to do before we actually start into one of these questions. First thing is, what could x not be? Okay, I actually asked that because it's a trick question. Okay, so when we have to worry about what x can't be, that's actually, it's when it's in the bottom. Yeah, when the x is in the bottom, that's when we have a problem. Is there an x in our denominator here? No, okay, so we actually don't have to worry about that one thing. Okay, but we will in a minute. Sorry. There shouldn't be. There isn't, exactly. Okay. Well, that is a question I'm going to ask you in the next couple of them, so, just get us thinking about that. But you always look at the denominator for that, right? So, look at the denominator. Is 14 ever going to be 0? No, it's 14. Okay, same thing with 7 and 3, right? So, we don't actually have to worry about the denominator, but we always look at the denominators for that. Okay? All right, so next thing we always have to ask is least common denominator. What is the least common denominator for 14, 7, and 3? So we need a number that's going to be a multiple of 14, a multiple of 7, and a multiple of 3. Right? So it's going to be a bigger number because they're all going to divide into it. Okay. So way back when, I said that was last week. I said take the biggest one and start looking at multiples of the biggest one. So let's start with 14. Okay, 28, and then times 3 is 42. 14 times 4 is 56, and I'm just going to stop right there. We can keep going, but one of those might work. Does 28 go into 4, or does 14 go into 28? Yes. Does 7 go into 28? Does 3 go into 28? And no. It doesn't. Okay, it goes into 27, right? Not 28. Okay, so 28's not it, but so how about 42? Well, okay, 14 definitely goes into 42, right? It's on the list. Does 7 go into 42?
42 works.
Okay, 42 does? Okay, and 3? 3 goes into 42?
Yeah, it goes into it 14 times.
Okay, perfect, because it's 14 times 3, so yeah, that works. Okay, so 42 is our least common denominator. Okay. Now, none of this is actually to trip you up, okay? This is a refresher. So, okay. I hope you know I don't derive enjoyment from confusion or anything like that, okay? I don't. I promise I don't. Okay, so what do we do with that 42, though? Yep, I'm going to put things in parentheses and do 42, 42, 42. Okay. Okay, and we get to divide some things, right? So 42 divided by 14 is our first denominator. 3. Okay, so this would be 3 times x plus 2. Okay, and then 42 divided by 7 is 6. Okay, so this would be 6 times 2. So we're dividing by the denominator and then multiplying by whatever's in the numerator. Okay, and then 42 divided by 3 is, you said it was 14. Okay, so plus 14, parentheses, x minus 4. Okay. Just like on that last question, probably wanted to distribute, get rid of those parentheses. So you get 3x plus 6 equals 12 plus 14x minus 56. And please tell me if I messed something up. I've done that before, okay? It happens. I hope you'd correct me just like I might lovingly correct you, okay? Gently, okay? All right, is that all good? Same things? Okay, all right, so let's see if we can combine some like terms.
12 minus 56
Negative 44, okay, so 14x minus 44 on the right side, and yep, there's 3x plus x on the left. Okay, so let's see if we can move some terms around.
You can either subtract 6 from both sides, or you can add 44 to both sides.
Okay, that's true. Which one would you rather do?
44. You subtract it.
Oh no, we have to take a vote. Oh, okay.
I mean, I agree with that, but also I think it'd be a little bit easier to have that x on the left side. Yeah.
Okay.
Like having the x on the left side.
Okay, so we want to move can we agree with that? X on the left. Okay, you don't care, Levi. Okay, we'll do it however you want, and we'll compare. Okay, so all right, we'll go ahead and move the 14 to the left, and that means the 6 will go to the right. Right. Okay, so let's subtract 6. Subtract 6. Now I'm going to do all this in one step. Right? Yeah, I don't know if you've noticed, a lot of these questions we sort of go from top to bottom, but the way I organize this, there's actually a ton of space over to the right I haven't used yet, but we may have to use that. We might. And if you find on the exam there's not enough space on your paper, okay, you can use, I'll get you some extra paper. Okay, don't worry, don't make space an issue if you find that you don't have space. Okay, so let's see, 3 minus 14, that's negative 11. Well, we actually should get the same answer either way. Should get the same answer either way. Yeah. So let's see, so I got minus 50 there. Same thing? Y'all agree? Okay. So if you divide by negative 11, that means x is equal to 50 over 11. And I don't think that's going to be a very nice decimal. No, 11's usually going to be weird. Okay. The question is now, do we want to check this? You don't? Okay.
We trust ourselves.
Okay. All right. Fine. I'll take it. But just remember, you could go back, you replace the x with 50 over 11, and you go through, and hopefully both sides are the same. All right, but if you are voting no, then we'll just call it a day. Oh, and I guess I should also say, remember, we can always write these, like on your review, it's going to have you write them as little solution sets. So you could write it that way as well. Okay. Next, what can x not be equal to? 0. Okay, good, because x is in the denominator. That's when we care about that. Okay, what's our LCD? It's come denominator. That's okay, 2x, because we want the x to cancel out in the denominator, but we also want the 2 to cancel out. Okay, so then we're going to multiply everything by 2x, like we did on the last one. And don't forget, I just drew over it, but just don't forget that actually is a -1 right there, so we don't want to mess up our signs in a minute. Okay, so what's going to cancel out? Okay, from the first one, the x will cancel out. So we get 2 times -8. All right, and the next term? Okay, so we're just left with 3 minus... Anything cancel on the last one? No? Okay. Yep, just 1 times 2x, so just make that 2x. Okay, so let's see, that'll be -16 equals 3 minus 2x. If we subtract 3 from both sides, it'll be -19. Okay. I think we're going to do another fraction, but it's okay. That's 2x. Okay, so we're going to divide by -2, right? Okay. So then that means x equals 19 over 2, which would be 9.5, I believe. Yeah, because should be positive. Yeah, okay. Yeah, so 8. If it was 18 over 2, that'd be 9. So it's 1 more than that. So yeah, 8. So it'd be 9.5. Okay. So if you wanted to go check this, there's one thing we have to do. Plugging it back in is optional. I'm not going to make you do that. But, well, at this point, I'm not going to make you do that. Again, there are some that you have to, but this is not one of them. The one thing we have to do, though, is check and say, is it equal to 0? Are we equal to 0? Okay, so we can't, this cannot contradict what's up here. Otherwise, it would be no solution. Okay, if those two are in conflict, then it's no solution. Right. So we'll just go with 19 over 2, which again, we could write. Some people prefer the set notation, the solution set. Some people don't. I know your homework has you do that, so that's why I'm just showing you both. Continually. Okay. All right, we have one more of these rational equations. And this is actually from 1.6, this next one. So what we did yesterday, solve the rational equation. 4 over x minus 2 minus 1 over x plus 2 equals 5x over x squared minus 4.
We're going to factor x squared minus 4.
We're going to factor it? Okay, how does x squared minus 4 factor? X plus 2 and x minus 2. Okay. So I'm just going to scratch that out and replace it with that. Okay, that's good.
Now we're going to multiply least common denominator.
Okay, before we do that, what is the least common denominator? Okay, x plus 2, x minus 2. And what can x not be?
0.
Okay, 2 and -2. All right, so what, do y'all see where we're getting that from now? Notched out of the air, right? So what number, we ask, so the denominator can't be 0, so what number would make this denominator 0? 2 minus 2 would be 0. Yeah, -2 plus 2 would be 0. And the same thing for these here. Now, if you ever have an x by itself, I'm just going to go back to this one. If you ever have an x or something like this where there's no parentheses, it's not two terms together, then that's when we have 0. Okay. That'll actually come up later in another chapter too. But okay, so let's multiply by that big LCD there. X plus 2, x minus 2. I'm sorry for the chicken scratch here. But I'm multiplying by x plus 2, x minus 2. And hopefully some things cancel out, because that's kind of the goal, right? Okay, what is going to cancel out?
X minus 2 on that first one.
Okay, x minus 2.
Plus 2 on the second one.
Okay.
The whole denominator on the last one.
Okay. So now the big thing that's important here is what's left. So we've got a 4. Okay. Yeah, because it's minus 1 times x minus 2. So yeah, that works. Equals 5x. Okay. All right, well, back to distributing. That'd be 4x plus 8 minus x plus 2 equals 5x. Okay, so that would be a 3x plus 10. Okay.
Put x on one side.
Okay. Do you have a preference of which one we move? Let's not have World War III here, okay?
3
But,
to 5.
okay, let's move the 3 to the 5? Okay, sure. So let's subtract 3x. Since there's no constant on that other side, that's a good idea. So that'd be 10 equals 2x dividing by 2. Is that in conflict with anything here? It's not in conflict. All right, so good. And 5 is at least a valid solution. Now, if we, again, it's still a good idea to go back and plug your numbers in because we could have made a mistake. If you ever find that the two sides are not equal, we have a problem. Okay. You have any questions about this? Anything so far? Or are we good to keep going? All right. Okay, because we kind of shift gears a little bit. We'll get back into the quadratic stuff. All right. Let's jump over here to simplify and write in terms of I. And this is negative 12. This is the numerator is negative 12 plus the square root of negative 45 all over 60. Okay. So first thing we really would need to do is look at square root of negative 45. Could we simplify that any? Okay, yeah, so if you put that in the calculator, it is undefined. And that's because the square root of a negative is going to have a certain letter in it. An I. Okay, which again, I is actually a number. I'm saying it's a letter. Okay.
So the I states that it's going to be a negative square root.
Yes. So if we have a negative in the square root, we're going to have an I in our answer. Okay. So now the other question is there a perfect square? And the way I did this before was I said, okay, negative 1's a square root. That's I, perfect square. But is there another perfect square? It goes into 45. Do you want me to write my list down?
Yes.
Okay. All right, so let's see. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. And you could figure this out in your calculator, right? If you really needed to. You could type in 3 squared, then 4 squared, then 5 squared, and keep going. Okay. I'm going to stop at 49 because that's bigger than 45. There's no way that goes into that. But of course, the list keeps going. So are there any of those numbers that divide into 45? 9? Okay, 9 times 5? Okay, so good, that's what we needed. 9 times 5. Okay, so that means that this square root becomes 3i square root of 5. 3 because it's the square root of 9. I because it's the square root of negative 1. And then square root of 5 because that's what we have left. We can't actually simplify that part. Okay, now this, as far as we're concerned, was scratch work, right? This is scratch work. So let me go back over to the original thing, and this is negative 12 plus 3i square root of 5 over 60. Divide by 3. Okay, we can actually reduce this fraction. 12, 3, and 60 all divisible by 3. So if we divide those by 3, that would be negative 4 plus I square root of 5 over 20. Okay. Now, because the homework accepted the I behind the square root or in front of it, okay, we've had to talk about this. Do what? How so? Are you saying the 4 and the 20? Yeah. Well, okay, so this isn't something I don't think we ever did, but you could actually write this a little different. And is it okay if I do that? I'm still going to say that is the answer. If you write that on the test, you're good. But another way you could actually write this would be negative 4 over 20 plus I square root of 5 over 20. Like you could split it up into fractions, and then you actually could simplify the 4 and the 20. But I'm not going to, I'm fine with either one of those. So that would be negative 1/5 plus I square root of 5 over 20. And now since the 5's inside the square root, it wouldn't go anywhere. But so this would be another acceptable answer to that question. But the one I have boxed in is what we did in class, and I'm perfectly fine with that.
Question.
Yeah.
Because I'm a little behind.
Okay.
So how we got the negative 4 over 20? Did we divide each part of that, all three parts, by 3?
We did, yes. Yes. In fact, here, I better just make that explicit. Yeah, that's what we're doing.
Where'd you say you get the 3 from?
Oh, the 3i was from over here, so we had the 9, square root of 9 is 3.
Oh, okay.
Okay. Okay, you're good with that. Okay.
That's divided.
Yeah, yeah. Okay. We might have to do this sort of thing again when we get to the quadratic formula, because that has a big square root in it. So we might actually have to do this again. That's why we even do this right here. Okay. All right, well, here's our next one. It's solve 5x squared plus 45x equals 0 by factoring. Now, there are, as you've seen so far, that there are a lot of kinds of factoring. One is where you have something like x squared minus 6x plus 9 or something like that, where you have something with 3 terms. And then there's the difference of squares, like the x squared minus 4. So there are lots of different ways we could factor things. So I'll just want to point out again, this is an example of a factoring question, not necessarily the one you might see. Just so recall, you might go back and go, wait, how do I factor again? And look back over that if you're not sure about that. And again, your online review is a good source of questions. No. Oh, no, not during the test. I mean, as you're studying, yeah. Well, that's a good question. Okay, actually, that's something else I'll talk about after I finish the video. So ask me that again later. Okay, all right, so does this factor, 5x squared plus 45x, how does it factor? Okay, all right, it just does. Okay.
He's not wrong.
Okay.
Well, it says in the question that you need to factor it.
I gotta say it must be.
It does say factor.
Okay, fine. It does say factoring, so there's a good chance that it factors. Okay, so what were you saying? 5 goes into 45 and 5, right? Okay. Is there anything else that goes into both of those? 5x. Yeah, there is actually. So let's take.
Parentheses,
Uh,
x plus 9.
Yep, that would be an x plus 9. Okay. Now, once we've got something factored, and this is again one variation on factoring. Then we want to set, once we factor it, we want to set them equal to 0. So 5x equals 0 and x plus 9 equals 0. So what is going to make this equal to 0? 0. We kind of did that earlier, didn't we? With the 2x in the denominator, we go, oh, that's 0. That's the same thing there. Anytime you have just an x sitting alone like that. Okay, and then x plus 9, what would that be? And negative 9, yep. So 0 and negative 9. And we could go back and plug those in. Again, you can always check your work. Here, I'm going to check one of them real quick because it's really easy without writing anything down, okay? 0 squared is 0. So this is 0. 45 times 0 is? 0 plus 0 is? 0. Okay, so 0 actually is a solution because you plugged it in, you do get 0. Now, the same thing should happen with negative 9. So if you're in the mood for checking your work during your exam, which I'd suggest, then, go back and do that. Okay. Let's see. The next one we have actually, I'm going to go a little out of order. Let's go straight down. This one's the square root property, because this is the way we covered them in class. Square root property. What do we do with something like that?
Get rid of the exponent
Get rid of the exponent, okay?
by doing the square root.
Yep, by taking the square root. So I'll just write this right here. Okay, so the left-hand side is just going to be x plus 3. And then this is going to be, there's something we always have when we take the square root like this. It's a little symbol. Plus or minus. All right. So plus or minus square root of 93. Or 98. Sorry. On what? Oh, okay. You don't actually, whenever you go to on the online stuff, you don't have a plus or minus. So you actually have to write it as two separate things. Yeah. There is a way to type it, but it scores it like you didn't type it there. So. Okay, but before we actually move any further here, the square root of 98, does that simplify?
Or it simplifies.
It's not a perfect square. That was me. Okay, it's not a perfect square, but
You're making it into two different squares.
yeah, I think it does actually simplify that because, well, I just happen to know that 49 times 2 is 98. So this is I'm just gonna go off to the side here and say square root of 98. The square root of
Would that be called simplified?
yes.
Okay, that's what I thought.
So you put the 2 in front of the square root of 49?
Other way around. What's the square root of 49? That I can do. 7, and I can't do the square root of 2, right? Yeah. Okay. So this is going to be plus or minus.
So it's going to be 7?
Yep. 7 square root of 2. Yep. Okay. That comes up a lot. So you kind of just want to go, wait, does that simplify at least for a second? And at least convince yourself that it doesn't. Okay. Bless you. So at least convince yourself that it doesn't simplify by trying to. And if you can't find it, then, maybe it doesn't. Okay, so what is x then? What do we do with that plus 3 there? We have x plus, yeah, we need to move it over. We want just x.
Subtract it from the 7. Not from the square.
No, so it's,
Because then that would change the 49. Oh,
yeah, so it's actually going to just be negative 3 plus or minus 7 square root of 2. It's going to be a separate term there. Okay, now if you were typing this on the computer, like I was saying earlier, you'd actually want to do this. Negative 3 plus 7 square root of 2, comma, negative 3 minus square root of 72. So you'd actually want to separate it into because there really are two solutions here. The plus or minus means there's two of them. However, if you're doing this on paper, and I'm just looking at written work, then if you write this, I'm going to assume you meant this. Does that make sense? So I would assume that means this, but on the review, you're going to have to actually separate it into two things. Okay. And we're not going to check that one. Okay. It's a little more work to check that. Okay. Well, let's slide over to the left. Solve this one by the square root property. Oh, that one's square root property too. Look at that. All right. 2x squared minus 9. We do. We need to isolate our x squared there. So how do we do that?
Move 9 to the other side.
Okay. When we say move, what do we do with that? Yeah, we're going to add 9. Okay, so that's 2x squared equals negative 8? Negative 8? You agree? Okay.
Square root of both.
Not yet. Almost.
Divide by 2 first.
Yep, divide by 2 first. Divide this by 2. So x squared equals negative 4. Now we can do that. Now we take the square root. Okay. So square root of negative 4. 2i. Yes, okay. Now 2i because it's negative. So we have 2i, and there's one thing we don't want to forget. Plus or minus. Okay. Plus or minus 2i. All right. So if I wanted to write my answer as a set, like we've been doing, I'd have 2i and negative 2i.
I thought the I represents the negative.
That's only if the negative in the square root.
Yeah,
Oh.
but it is hidden. If you look at it, it is in the square root.
What was the last one?
Did the last one need an I?
No.
No. Yeah, it was
The
a.
number is a positive number in the square root.
Yes, if it's a positive in the square root, then we don't need the I, but if it's a negative in the square root, we do need that. I hope this is tying some loose ends together.
Yes.
All right. Okay. Okay. Well, next page. Let's see. So from here on out, let's see. We've got completing the square, quadratic formula, a ladder, and we got one of those radical equations. It's actually one of the harder ones. So, okay. So let's take a look at completing the square. First off, is it in the right form for that? It is. Okay. If it wasn't in the right form, we'd fix it. Okay. So we want it to look something like this, right? X squared plus bx equals c. We want our constant over on the right side, and we want it just an x squared. So if it wasn't like, if it said x squared minus 4x minus 11 equals 0, we'd have to move the 11, right? We'd have to do something there. Okay. Okay. And then there's this little bitty formula we kind of use in the middle of things to find the number we add to both sides. Yeah? Squared. Yep. Okay. B divided by 2 squared. So we're going to have to do something like this. Okay. So what is our B here? Negative 4. Okay. So let's take negative 4 divided by 2 and then square it. Uh-huh. Two times 2? 4. Yeah, okay. So it'd be 4. So we're going to add 4 to both sides. So we've got x squared minus 4x plus 4. And we're adding it to both sides. So we have 11 plus 4 as well. Okay. So 11 plus 4 is 15, of course. But x squared minus 4x plus 4, that's going to factor. Every time it's going to factor, and it's going to factor really nicely. So if you're not remembering what it's going to be, what two numbers are going to add to be 4, but multiply to be 4, but add to be negative? Yeah. So what two numbers are there? So 2 and 2? Oh, negative 2, negative 2. Okay. So this is going to be x minus 2 and x minus 2. And the reason I say this is really nice is because that's gonna actually be x minus 2 squared. Did you say we did that for nothing?
We're just following stuff.
Well, we actually did this so that it would look like. Okay, I'm gonna slide back up to the last page. We did this so that it would look like this one right there, x plus 3 squared. So we can actually then do the square root property. That's actually why we did it. And why we do the b over 2 squared anyways, but yep, we are completing the square. We're making it into a squared term like that. So we're actually we're completing the square, adding the 4 so that it can be like this. We just made it happy. Okay, it's complete now.
And now we do square root of both sides.
Now we can do the square root of both sides, yeah. Square root of both sides. So that'll be x minus 2 equals, what do we need to write here? That little thing we always forget. Plus or minus. All right, plus or minus square root of 15. Now, I would be remiss if I did not say, can we simplify square root of 15?
No. I think it's
Okay, let's see. So, does 16 go into, okay, obviously no. Does 9 divide into 15? No. Does 4? No. Okay, this does not simplify. But we better ask that, just in case. So yeah, none of our perfect squares divide into what? Yeah, they're not perfect squares. We'd have to look for perfect square. Yeah, yeah. Okay, so if we add 2 to both sides,
the 2 goes in front of the plus or minus, right?
yes, it will. So that's x equals 2 plus or minus square root of 15. And then if you were writing this, if you're putting this in your review, you'd have 2 plus square root of 15 and 2 minus square root of 15. But again, either of these on paper is acceptable, but if you were doing it on a computer, you'd have to split it into 2 like that. Okay. All right, what about the quadratic formula? We solve this using the quadratic formula. There are a couple of things we have to do to use that. But what is the quadratic formula? That's kind of important.
Negative b
Mm-hmm.
plus or minus negative
Square root, I heard that.
square root of b squared plus 4 times a
It's not plus, but you're right. It's a 4 times a times c
over 2 times a.
2 times a all over 2a. Yep. Together, you've got it. Okay.
I was trying to do it from memory.
Yeah, no, that's good. That's good. What was that? Did you have a question? Huh?
Are we supposed to memorize, like, to have this memorized? Like, are we supposed to know that formula by heart?
It's not a bad
I-
idea.
He said if you send him to write on the board.
You said you weren't
Oh,
gonna
yeah,
forget.
oh, yeah.
Yeah.
I forgot.
Okay. All right. Yeah.
That's my bad.
Okay.
I forgot.
All right. So now this formula only works if your equation is a certain form. Is this one in the right form?
No.
Okay. How do we need to rearrange
We
it?
have to make x, we have to put,
You have to put it all on the same side.
Okay. Yeah, it has to be on the same. It has to be. It has to be.
Zero's gotta be by itself on one side.
Yes, it has to be equal to 0. Okay.
Yes.
So what do you want to move around?
I would just move the 9x,
Yes.
because then I don't have to move
Okay.
all the rest of it over.
Okay, so that's fine. So if we do that, if we subtract 9x from both sides, that'll be negative 9. We subtract 9x squared. Okay, it's a thing there. That's a negative 9x squared plus 10x plus 2. Okay, so A, B, and C are, what is A? Negative 9. B is
10.
10, and C is 2. Now let's put this in there and see if we can simplify our square root. All right, so let's see. Negative b, so that'll be a negative 10, okay, plus or minus square root of 10 squared. And I really ought to put parentheses everywhere I plug things in, okay? It's just a good habit to have. So b squared minus 4 times negative 9 times 2. That's our c. All over 2 times negative 9. Now, next thing you want to do is plug everything that's under the square root in. Unless, let's see what we get there. So 172, okay. So that's 10 squared minus 4 times negative 9 times 2. Okay, I get 172 as well. Over 8. All right.
Negative 8.
Okay. So let me just go ahead and put this in. I have negative 10 plus or minus square root of 172 over negative 18. Now, we really should see if we can simplify the square root of 172, okay? But it's not negative, so there's no I involved in this, right? We know that. But if you notice, every time we have a square root with a plus or minus, we have a plus or minus in the quadratic formula too. Okay, well, let's run down our list of perfect squares. I'm going to start at 10 squared because that's 100. So let's say, does 100 divide into 172? No. Okay, next is 81. No, that's 9 squared. That's a 64, because that's 8 squared. Shucks. Okay, let's see, 49. No, wait. Is that the next one, 49? Yeah, 49. 8 squared, 7 squared, so 49. No. Okay, 36. Okay, 25. I just had a good feeling this was gonna work, but no. 16.
No.
Okay, how about 9?
No.
How about 4?
Yes.
Yes. Wow. Okay.
Wouldn't that be a positive 10? On the,
Oh, well, because it's we have a negative b in the formula.
yes, but b is negative, negative 10.
Oh, well, we move the 9x squared over
Oh,
here.
you're the 9, okay.
Yeah.
I did it too.
But if you did it the other way, okay, you should still still not getting the same things though. You do. But yeah, so it would be. So you probably what you had then was a positive 10 square plus or minus square root of 172 over positive 18. Yeah. Okay. So yeah, it all comes out in the end. Okay. So 4 divides into 172. So then what was it? 4 times what? 43. Okay. So the square root of 4 is 2.
So we put 2 in front of big.
Yeah. All right. So negative 10 plus or minus 2 square root of 43 over negative 18. Okay. Now, we can't actually reduce that because of that 2. We can reduce this. And what do you think? What do you want to divide by? 2? Okay. Those negatives sometimes make people feel funny, so they might divide by negative 2, and it works out 2. But if we divide by 2, that'll be negative 5 plus or minus square root of 43 over negative 9. And because there's a bunch of minus signs in here, we could make this 5, positive 5, plus or minus square root of 43 divided by positive 9, and that would actually be fine. We can divide everything by a negative, and the plus or minus would become a plus or minus. So, anyways, that's just an aside. But there we go. Oh, and I guess I probably should list these out, shouldn't I? There we go. If I wrote these as a list, again, for thinking about your online work, it's 43 over negative 9, and negative 5 minus square root of 43 over negative 9. And there is that whole question in one little spot. Okay. Are we all right with this one? Hanging in there? Okay. Well, we have 2 questions left. So the next one we've got is all about a ladder. So the base of a 10-foot ladder is 5 feet from a building. If the ladder reaches the flat roof, how tall is the building? And then give your answer as a simplified radical. We'll have to do that. And as a decimal rounded to the 10th place. Does anybody immediately start thinking about, have a picture in your head? Okay. Yeah. What would you draw for that? It's a triangle? Okay. So, well, I've got plenty of space here, so why don't I just do this? Here's a triangle. Okay, so what do I need to label here? Okay, down here it's 5 feet. So
The ladder is 10.
the ladder is 10 feet. Okay. Okay, and what are we trying to find?
How tall the building?
Okay, so what part of this triangle will be the,
Right side.
yeah, the other leg of this triangle? Okay. So I'm just going to call it, label it X, and we'll go from there. All right. There is a way to relate these three, right? A squared plus B squared equals C squared. So in this case, which one's our C?
Two.
Mhm. All right, it should be the longest side of the triangle, so the 10. The 10 would be our hypotenuse. So that's our C. All right, so we've got 10 squared equals x squared plus 5 squared. Okay. Now, because 5 squared is 25, x squared plus 25 equals 100. That's 10 squared. And we know how to solve something like that, right? Yeah, what do we do?
Add 25 to the sides.
Subtract. Yep. We're going to subtract 25, and then we will take a square root. So let's see. Subtract 25. That's 75. And it's square root of 75. Does that simplify? Let's see. I'm going to run down my perfect squares again. So 81 is the one that's just above that. So that doesn't divide into it, of course. Then we have 64. Then we have 49. Then we have 36 and 25 and 16 and 9. Do any of those divide into it? Do what? 25 and 3. Okay. All right. So I'm kind of going over here to do my scratch work. All right. So that's 25 and 3, which means
25
it'll be 5. So 5 square root of 3. Okay. Don't you wish you could zoom in on your paper sometimes? Okay. Write smaller. Okay, so 5 square root of 3. So I'm going to write this over here. It is 5 square root of 3, and I believe that's in feet. Yeah. Okay, so let's say that again. It's going to be a little bit more than 5 foot tall, actually. So this is the simplified radical. So let's go. Yeah, good. We want it as a decimal as well. So put 5. So I'll tell you, square root of 3 is like 1.7 something. So it'll be more than. Wait, say that again. 8.6. I thought I heard 4. Okay, 8.66. Which we want to round that to what place? The 10th place. That's one decimal place. So yeah, 8 points. Hmm? Yeah. Well, tell me what that is here in a little bit. Well, okay. I still want to see it. All right, so the simplified radical is 5 square root of 3 feet. And the decimal round of the 10th place, 8.7 feet. So it's approximately 8.7 feet. Okay. Our last question is one from yesterday. We have a square root. Solve the equation. The square root of 4x minus 20 equals x minus 5. So, what were those steps we followed yesterday? Isolate. Is it isolated? Yes? Okay. Yep, the 2. We're going to raise was the word we used. So we're going to raise it to a power. Just a second power.
Solve and then check.
Solve and then check. All right, so we're going to square both sides. So it's already isolated. We're going to raise it to the second power. So that we have 4x minus 20. And be careful with x minus 5 squared. Remember, that's actually something we have to multiply out. So let's see. X minus 5 times x minus 5. What would that be? Okay, we have an x. Okay. So, and I'm just going to add one detail to that. Remember, we have the minus 5x and the minus 5x there. So that would be minus 10x, yep. Okay, plus 25. So those are all the pieces we get there. X squared minus 5x plus 25. So x squared minus 10x plus 25. And that's what I'm going to put over here. Let me just work on that. Squared minus 10x plus 25.
This is where we start putting stuff over to the side.
Yep, this is where we move things over to the other side. So I would really like the x squared to still be positive, so I want to move things over to that side. So what am I going to do with the 4x? So 4x. What do I do with the 20? Add 20. Okay.
X squared minus 14x
14x.
plus 45.
Okay, plus 45. All right. The solve part is the biggest part here. Okay, so we need to factor this.
To get rid of the x squared.
Mm-hmm. So it'll be something like this. So we need two numbers that multiply to be 45 but add to be negative 14. Multiply to be 45 but add to be negative 14. Okay, minus 9 and minus 5. Yeah, two negatives that multiply to be positive and add to be negative 14. Okay. So what would make each one of those 0? Yeah, positive 5 and positive 9. Okay. Yay, we're done, right? No,
No.
we're not. We have to check them. We have to check them. One of these could be invalid. Now, I will just tell you, there are times when both of them are valid. There are times when neither one of them is valid. And there's times just one. So we need to kind of check. We do need to check all these. So let's just go over here to x equals 9. And I'm going to put in my calculator square root of 4 times 9 minus 20. Oops. Okay, and that should equal 9 minus 5, which is 4. So if x equals 9 is a solution, then those both sides will be the same. And I'm going to go ahead and write for 5. I did square root of 4 times 5 minus 20. And that should be equal to 5 minus 5. Okay, I'm just going to talk through this. So 4 times 9 is 36. 36 minus 20 is 16.
It's not even 4.
Wait. Hold on. So 4 times 9, 36. Minus 20, that's 16. Square root of 16 is 4, right? That one's actually right. Okay, so equals 4. Okay, what about the other one? They both work. Look at that. Okay. Now, this is the only time that well, I shouldn't say only. There is maybe some time later, but the only time on this exam that I'm going to say you have to check is this. Okay, because this is, I didn't predict that was going to happen. Okay, so just happens sometimes. So we can write this as 9, 5, and either one of those. I say it again? Yeah, so I'm taking the two numbers that are there and putting those in the reduction. Back in the original way. Okay. All right, and I'll say one more time before I kill this recording that this is not comprehensive in that there are other variations you could run across. We kind of talked about a bunch of those we went through, but just keep that in mind that this is not the end of your studying, I hope, right? All right.